Good. Thank you, Robbie. All right, welcome again to Space City Rocketry's general meeting. This is the first time seeing everyone in one of these general meetings for a few weeks. So I'm very happy to see all of y'all. So just the overview for today, some of the things that we're going to be going over, shout outs. Definitely going to be talking about the PDR and some of the feedbacks we got. A lot of stuff that the sub teams now have to change. We might not go over it at the beginning, but the sub team leads themselves will speak more on that on the sub team updates. And then we'll have the analysis lesson again, just because it's been so long. I think Robbie wants to come up here and present again. And then at the end, we'll save it for questions. But first, for shout outs, I want to give a shout out to the payload sub team or the new members in the payload sub team. So yeah. So they volunteer to be part of the payload sub team. We're gonna have our general meeting today. I'll speak about that later. The PDR crew also, thank y'all very much for taking notes, moderating online, and so on. Another round of applause for that. Of course, the sub-team leads, for helping with the report, helping with the slides, and so on. Thank you for that. So that's them. You know them. And all the members who put in work throughout the semester. We are so proud of you for just being here and just staying with us, learning about rocketry, and just being part of this amazing family. And then also thank you to Joe and Raj. We haven't officially announced it to everyone, but they're going to be taking over avionics now because B will be leaving to study abroad later in December. So we had to choose new leads. So thank you, V, Joe, and Raj for being such valuable members of avionics. Thank you. So we're gonna be talking a little bit about the PDR right now. And then, as I said, the sub-team leads themselves will be going more in depth. But the PDR was on the 19th and 20th of November. On the 19th, we talked about Zenith. So we talked about everything we've been working throughout the whole year, some of our engineering decisions, validations, and so on. And we got a lot of great feedback. Randy, Dom, Emily, Saturday, Eric, and a propulsion engineer came. It was great. I think we are definitely heading in the right direction, but there's still a good amount of work to be done. So here's some pictures from the PDR. I think we all look very good that day, and then you can see you can see Randy there in the back. So also when it comes to notes, so for the Zenith and SRAD PDR videos, they're up on YouTube. So if you want to give them a rewatch or you want to learn more about the rocket, you can always visit the AIAA YouTube channel. And videos for pretty much every meeting we have are up in there, so you can always watch those. And all the questions and feedback we got for from the PDR, you can see down there. They're on the drive, so you can access those. If y'all need the link, we can post them after the meeting today. Yes.
If a professor wants like the video, do we just send it to them, or did you already send out the video to?
We have not sent them out to the professors.
Okay.
So if you want to send it to a specific professor that we don't already have communication with, you can.
Well, yeah, it was the one who was supposed to attend, and he wanted the video since he went to.
Okay. Yeah, you can send it to them. Okay. So the biggest thing that we got from the PDR was the fact that we were only pre-PDR, we were only getting to 21,000 feet for Zenith, and a mistake on me and a couple of other members was we were a little confused as to how the point system worked. And so we realized that in order for us to get the most points available, we have to get as close as we can to 30,000 feet. So with 21,000 feet, we will receive 0 points of the 350 available flight points. That is the formula there. I know analysis will talk more about it when they present. So, you know, the thing we were asking ourselves even before the PDR is like, how do we get higher? And, you know, the question of like weight came up. We removed weight from the motor, not from the motor, from the rocket around like 10 pounds, and it only went up a few hundred feet. Maybe a bigger motor. We looked at the 03400, and again, just a few hundred feet higher. And then drag analysis, we'll talk more about that. So there is a huge decision that we have to made after the PDR regarding like our diameter of the rocket, which has affected all the sub teams in some way or another. So the next few days will be basically us trying to redesign everything. So that's what we go into the upcoming deadlines post PDR. So I've met up with Gustavo, we met up with all the sub-team leads, and we talked about certain tasks, things we want to redesign for every aspect of the sub-team and also their respective deadlines. So as of right now, and I know this sounds a little tight, December 5th is when we want to have everything redesigned. So making whatever calculations we need to do, making more simulations and so on. So around December 5th. With the exception of propulsion and SRAM proportion, since they're not really working with Zenith. And that's because Spaceport Progress Report is coming up on December 10th. It shouldn't be too bad. It should just take 2 days to write. It's just a few questions they ask. Although they do go on detailed, it shouldn't be much. I think we can definitely get that done. And then once we're done with that, we will also have like a week or two, maybe a week and a half, where we talk to the alumni. It's kind of like we did with the PDR, but not as formal, and just get, I guess, even more validation to make sure we're heading on the right path. And then December 17th to the 20th, so like a week and a half after finals, that's when we want to start ordering parts. So we'll, you know, talk with AIAA, the treasurer, everyone else, to order everything. And once the parts start arriving, that's when the hands-on work comes in and we can start assembling Zenith. And then also our ham radio license and our level 1 grind is going to be happening all over the winter break. So for us to get our ham radio license and also start building our L1s, hopefully launching in January or February. I'm going to be part of that, so I'll be at the lab working on that. So we'll be in touch with the hobby rocketry team so we can get help. So if you're interested in that, just message me or Gustavo or the hobby rocketry leads, B and Melissa for any more information. So now let's get more in depth with the PDR feedback. First off is analysis. Robbie, thank y'all.
Hello, everyone. For the update, I wanted to split it into kind of what we did pre-PDR, because we did make some last minute changes as to what we had been doing, and then some post-PDR stuff. So pre-PDR, we needed to update our nose cone drag calculations. If you were at the PDR or you watched it, you'll have noticed that our drag calculations in the beginning were just measuring the drag in pounds force and pretty much just summing every point along the graph. And we realized that was incorrect, and we needed to update that to reflect basically an impulse force, so pounds force times seconds. So we made that change, and then also some updated weights of recovery, which we overlooked, which didn't change too much, but it was just good to get all the correct weights in for an updated simulation. Post PDR, one of the biggest, or I guess the biggest thing we've done is completely redesigning what we're doing in OpenRocket and RockSim. And I gave my members a task of within either a 6-inch diameter or a 4-inch diameter, and using pretty much any of the 3 motors you see on the screen, try and get me to 30K. And I think the design as of right now that we're going with is a 4-inch diameter rocket. Before the PDR, we were talking about kind of what is our bottleneck, what's really keeping us from going past 21,000 feet. And I think it was really drag and the diameter. So shortening the diameter to 4 inches will let us reach the ranges that we were hoping to reach earlier. And with these designs, the N3301 gave us an apogee of 27,000 feet and 5800 an apogee of 28,000 and 034 an apogee of 29,000. And then I guess with the rest of the sub-teams redesigns, we hope to aid in justification of those designs and helping out in any other ways that we can. Thank you.
Thank you, Ravi. Yeah. I guess you can also like introduce yourself.
Yeah.
You know.
Hello, nice to meet all of you. My name is Josephine. You can also refer to me as Joe. We'll be going over what avionics did during the Thanksgiving break and what we did this week. So pre-PDR, we had a 12-inch avionics bay. However, post-PDR, we have downsized to a 6-inch avionics bay. Because of this, we have to redesign and have an entirely new avionics bay and tray, which Raj is working on currently. We also collaborated with recovery during the Thanksgiving break and talked about and focused on the ease of assembly and the single bay dual deployment. We also discussed the CO2 canisters. They will either sit partially or entirely on the avionics bay, which we have given the okay. We also discussed the placement of the terminals, which we have decided that it will be on the top of the avionics bay. And lastly, we are currently deciding on what to do with the antenna. We have a couple of suggestions thus far. We have a suggestion to place the antenna through the airframe. We also have a suggestion to just tape it to the side. Our main goal, keep in mind, is we are trying to prioritize keeping the antenna as straight as possible to get best optimal output. And this is just for a visual example. We just wanted to show you guys again what the avionics bay looks like. So that will be cut in half. And lastly, we have a when to meet social event for our, sorry, Raj and I are new sub-team leads, as you guys know, and we wanted to get a chance to know the avionics members a little bit better. Everyone else is welcome to come if you guys would like to. This is the QR code to fill out the when to meet so we can meet as soon as possible. Thank you very much.
Job. All right, payload. I'll present for payload for today. Yeah. Wait, hold on, Brian. I actually have a slide for it. All right. Meet the team. You know, as I mentioned before, these are the new members. Everyone here was basically already part of the team. There's a couple of them. Carlos, welcome to officially to Space City Rocketry, and also Andre. I think he might be online. So first payload meeting will be tonight, pretty much after general meeting. We'll pick the lead for payload, or like an unofficial lead right now to help with things. We'll talk more about tasks, deadlines, and hopefully next week we'll have a payload member presenting instead of me. There have been a few ideas floating around as to what we're gonna do for the payload. I know during the PDR, one of the feedback, like one really like good information we got or feedback we got was from Emily. She suggested maybe just improving upon last year's payload. There's a lot we can improve on from last year's payload, specifically talking about that camera or the lenses, or even just the whole thing. And also last year we used it was a 6-inch diameter rocket. Now we're going to 4 inches potentially. So we have to redesign a lot. We'll talk more about that tonight, yeah. Good you're here. Now propulsion, Tala. Here we go.
How's my audio?
Great.
All right. So for propulsion, one of the main differences that we got out of the PDR is that we are currently considering a third motor in addition to, first of all, our primary selection was the N5800 with a backup of the O class. Now we add another one to the mix, which is the N3301. Just because one of the things that was harped on a little bit was that we may need more impulse than we need with the N5800, and that we should maybe look at motors with a longer burn time, just for the sake of getting to the apogee that we do need. And then as far as actually getting the motor, the first batch of emails to vendors did go out last weekend, I believe. No substantial email response yet, though. And I only say substantial because the emails that I received back are not really helpful. But that should be taken care of. Hopefully by the end of this week, we should have some sort of solid answer, if not sooner. And as far as how the rest of the semester is going to shape out, as far as hands-on work at least, we will be having a mock motor grain assembly just for everyone to get a feel of how we're actually going to assemble it towards the end of next semester. So of course, not actual rocket fuel, but we will be making our own mock rocket fuel, which I'm excited about. So that should be one of the big things that we have coming up. And then after that, this is going to extend into next semester. We'll be looking at our mini test stand. So this is going to be the third one currently in the lab. And we also went over this during the SCR PDR. So it's going to be working on that. And yeah, I think that's it for propulsion.
Thank you, Tala. Bless you. The picture you see there is a mini test stand that our old project manager, Emily Humble, had made a couple years ago. It doesn't look very organized, so we want to improve upon that. And then on the right side is the thrust curves and all information for the N3301. I know it's not very clear on screen, but if you do a simple Google search for the N3301 thrust curve, all of this will come up. Next up is recovery.
Hello, everyone. So for the pre-PDR, we had a snatch force of 3,300 pounds, and we chose a lot of our components around this value. So the quick links, the U-bolts, and the swivel links were all really strong to make sure it could withstand this force, which meant that the budget for recovery was a little bit elevated compared to the other sub-teams, as well as some of the weight. It was a little bit higher just because we're using stronger components. Some of the cords were nylon, and some of the cord lengths were less than the length of the rocket. So after the PDR, we got some feedback on our snatch force calculator, and I ran the numbers yesterday with another calculator, and the snatch force is actually around 130 pounds of force, which is significantly lower than 3,300 pounds, which means that we don't need like quick links, swivel links, or tender descenders that are rated for like 6,000 pounds. So that's gonna save us a little bit of money, or actually a good amount of money, as well as a little bit of weight. We also met yesterday and decided the cords we're going to use. We were advised to use Kevlar instead of nylon because Kevlar can withstand a lot more force and is also really heat resistant. So that's what we met for yesterday, and we also chose the cord lengths. And moving on to after the PDR, basically, we just need to reevaluate a lot of our components, especially relating to how strong these components are and making sure that they can withstand our new snatch force. And we also have to finish up the initial design for the bulkhead. We met up today during the lab and worked on that, but we still need to decide some other factors before we can finish it completely. And once we do that, all we have to do is make sure that all of our decisions make sense and that our system is as optimized as possible. Thank you.
Alrighty, so for structures. As far as what we're sticking with the Von Karman nose cone that we had selected. Analysis said that they still potentially wanted to go through the drag calculations again, but we're gonna stick with Von Karman. And as far as the layout goes, we're still planning on having the payloads, the coupler, the avionics bay in the upper airframe, and recovery in the nose cone and attached to the avionics bay. I know it wasn't all discussed with y'all, but there was talk about moving some things in case we had to scrap other ideas, but instead we're just gonna go to a 4-inch diameter. So instead of having an internal MMM, we're now gonna have an external modular fin canister. These are 3 old designs that we had started considering at the very beginning of the semester, before we had switched to MMM and then back to MFC. So we'll be going back to considering designs for this. As far as what we're doing now, we're gonna meet a little bit tonight and we're gonna talk about the old designs. We're going to discuss, how we can improve upon them or if there's any new ideas we can come up with. And then we're also going to try and get a CAD as soon as possible of a finalized design, and then hopefully give it to analysis and run an FEA on it. And then also we need to find new pricing for the materials for the couplers, airframe, and nose cone. Since everything that we had previously is now gonna have to be, cheaper, so that's good for us. Then we just need to finalize materials for anything else that hasn't been determined yet, like for the MFC design. So yeah, that's what structure's been up to.
Ozzy, I got a message from you saying you might not be able to present, but are you here?
I'm going to be presenting. I'm Isaac Johnson.
Yeah, let's go, Isaac.
All right. So prior to the Thanksgiving break, we met with the capstone team and we worked with them to pour resin into the 3D printed mold that Ozzy made. And we kind of molded out the combustion chamber out of resin, and then let it cure over the weekend in the lab. And then on Monday before Thanksgiving, they took apart the mold, and they ran into a little bit of problems with it. I think a little piece might have broken off, but it's good now. And it was just kind of difficult to take out. And now the capstone team is preparing the final assembly of their prototype to present for their project, and we'll continue to develop the hybrid motor over next summer.
Thank you, Isaac. I think that was it as far as the sub teams go. Again, if you want to get like a real detailed version of everything that we talked about in PDR, of course with your sub teams you'll talk with that in your meetings, but also the notes and the video. They're great. I did have to edit some parts out with the audio, specifically the second day, just because you couldn't hear anything. So if you see cuts, random cuts, it's because there was just nothing there. It was just us standing. But all right. Now rocket lesson. So again, every week we want to just give a lesson on a certain thing about rocketry. Last time we had one was with analysis, but it was 3 weeks ago. So we were supposed to have the Kahoot today, but it kind of didn't make any sense of us having the Kahoot after 3 weeks. So we're just gonna go over again because Ravi did such a great job with this presentation. So you'll be back up here. And then next week it'll be recovery, and the Kahoot next week will be over analysis. And then propulsion. We don't know yet what day.
All right, everyone. I know my first lesson was so stellar that you actually remember everything, so I'm trying to speed it up a little bit. First, before we answer the question of what is analysis, we must answer what is engineering. It is the application of scientific and technical skills to a planning process. Science-based analysis and technical skills in the planning process provide confidence in the execution of design. And the three pillars of design acceptance are needs, risks, and credibility, which is where we come in. So analysis, our goal is to provide validation of design. In general, engineering project plans require more attention to physical, quantifiable traits and performance, and quality and credibility of technical evidence and decision-making. And these are two, I guess, categories or requirements that Spaceport also takes into consideration when evaluating us at competition. So the three main branches of analysis include the computational mechanics, or CAD, FEA, and CFD, some apogee simulations with OpenRocket, RockSim, and some mathematical models. So today, within these three branches, I'll be talking about CAD, FEA, OpenRocket, and then some stuff on rocket stability. So first off, what is CAD? It is a computer-aided design. It's the use of computers to aid in the creation, modification, analysis, or optimization of a design. Some examples of some CAD softwares you may have experienced are AutoCAD, SolidWorks, and the ones we're grateful to use, Siemens NX. And then within the team, we use CAD to create a database of past, current, and potential designs, and also hopefully use them as inputs for FEA and CFD analyses. That leads us to what is FEA. It stands for Finite Element Analysis, and it is the process of simulating the behavior of a part or assembly under given conditions so that it can be assessed using the finite element method. And I like this graphic here because it shows you kind of have a big problem to start with, and the finite element method breaks that problem into a finite number of smaller problems, then solves those problems individually on its own before reassembling and putting back together as the solution to your major problem. So the general process, first, you're going to define the problem. So what do you really want to know? What do you want to gain? Then you'll create a model using the CAD software, as we talked about earlier, just creating as accurate of a representation of the object or system as you can. And also what we've learned, also, I guess, through our experience is that it's not always as accurate of a model, but really how can you learn to simplify your model to still give you a good result, but not necessarily at the same level of complexity. Then you'll define your loads, constraints, and then mesh the model. So this is where you define the forces that your system will undergo, and then identify the points of constraints. Then you'll define what analysis you want to perform, what data are you really looking to gain from performing the simulation, and then you'll submit it to the solver and post-process. So you'll submit it for simulation, and then after the simulation, process your results and determine what you can conclude from that. So how does that apply to us? Well, we really want to learn where FEA is necessary and also specifically understand modes of failure. Something that Randy has always pointed out at the PDR and beforehand is that I want you to think about all the different ways in which your rocket can fail and then design around that. So that's one of the ways we think FEA can help us out. Also identifying and applying potential analyses and really just learning more about the process in general. And as a bonus, the judges at Spaceport America do love to see some finite element analysis done on your systems. So now moving on to rocket stability. A rocket can be described as stable, overstable, or understable. And different factors such as the center of gravity, center of pressure, and the diameter of the rocket all contribute to a rocket's stability margin. And you can see the symbols we use for center of gravity and center of pressure there, and then the diameter of the rocket. So center of pressure and center of gravity. Center of pressure is the point at which all aerodynamic forces, or generally just lift and drag, act on a rocket. And this must be located behind the center of gravity and also above the fins. And the center of gravity, pretty self-explanatory, just the average location of the rocket's weight or the center of mass. And it's also the point at which the rocket rotates about itself. So now stability margin. This is used to relate the distance between center of pressure and center of gravity and it is measured in calibers. This caliber is just one rocket diameter, or whatever the diameter of your rocket is. So for Zenith, if we go with 4 inches, our I guess one caliber will be 4 inches. In general, if your stability margin is greater than 1, you're considered stable. Although per the Spaceport America Cup design regulations, nominal stability is between 1.5 and 2. And if you're greater than 2, per these design regulations, you can be considered overstable. So there's a nice little diagram of CG and CP and how they act on the rocket. And yeah, I guess if you have any questions about that, feel free to ask. But there's also a more detailed explanation of this in the first analysis lesson that you can go back and watch on the recording on YouTube. Any questions? Yes.
When will the FEA be done?
Fortunately, I'll be leaving the team and not completing them. Just kidding. Timeline, I want to say by the end of 2021. I think we can get something out by then, but I know that's also kind of clouded because the main priority right now is to try and help out with redesigns and maybe, you know, an MFC FEA and how that can help. So I think end of 2021 at the latest. Any other questions? Cool. Thank you, everyone. Appreciate it.
Thank you, Robbie. Yeah, as it turns out, making an FEA for something like an MMM, it's pretty hard. So, oh wait, what? Oh,
Also, this is a 4-inch diameter tube. And I think for the Oberon people, this it really took me by surprise. And yeah, so I'm pretty busy with midterms tomorrow, but after that, I will be running some simulations on a 5-inch diameter just to help out recovery with their space. So it's something in the works, not fully decided yet, but this definitely did take us by surprise. So feel free to come up and look around with it. Thank you.
yeah, all the sub teams are working very hard right now and communicating with each other to get Zenith completed. All right, any general questions about anything SCR coming up next couple weeks? I'm checking the chat too, just in case anyone has a question there. No questions? Cool. All right. Well, if you have any questions, you know, after the meeting's over, there's Gustavo's a nice email there. And also there's like you can always message us on Discord about anything. I know that finals are coming up. People have midterms this week. So it's a little stressful right now, but of course, if y'all need any, like, you know, I already talked with the leads, you know, if we need like an extra couple of days to get something done, you know, we can always move it because your classes are the priority right now. But I'm excited, y'all. I'm excited to see what the final Zenith design will be in the next couple of weeks. I think it's going to be very exciting, especially when we get that CAD and we get like a real detailed CAD and we can do like the thing where you split it in half and you can see the inside. It'll be cool. It'll be great. So as far as how the winter will look like when it comes to meetings, we still haven't decided on that. But next week we'll make that announcement. Thank y'all so much for all your hard work. Oh wait, hold up. Now you. I'll see you next week throughout the week.